Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another series on design principle that is mainly solid design principles. So these solid design principles they lay a foundation on which we can build clean maintainable architectures. Why solid? Why do we need solid? So first, to take care of code fragility, code rigidity, and technical debts. So we'll see one by one each of these problems. So what is code fragility? Fragility is the tendency of the software to break in many places every time it is changed. What is code rigidity? Rigidity is the tendency for software to be difficult to change, even in simple ways. Every change causes a cascade of subsequent changes in the dependent module. So we change at one place and there is a replication of subsequent changes in different modules. Technical debt is cost of prioritizing fast delivery over code quality for long period of times. Due to delivering fast, we sometimes skip the quality of the code. That results in the technical debt. So whenever we write code or whenever we do coding, we choose between speed and quality, right? So whenever we have a bug fix or a fast delivery that we have to make, so we always choose the easiest fix or the change, right? Because it's fast, so it results in poor written code. Whereas if we focus on the code quality, it takes some more time, right? It adds a bit of complexity, but at the end it results into the maintainable code. So let's talk about more about technical debts. So no matter how good your team is, the technical debt will accumulate over time. So we cannot bypass the technical debts. Second, if it is left uncontrolled, then it will slowly lead to the killing of the project. Like, project will be hard to maintain. So we need to find the right balance between the speed and the quality to keep the technical debts under control. How we can minimize the technical debt? By constantly refactoring the code, right? Making sure it is loosely coupled, it is testable, and it's easy to understand. So how we can reduce the technical debt? We can write some code, we can refactor it, again we write some more code and we refactor it. So continuous writing of the code and continuous refactoring, you know minimizes the technical debt. So let's now dive into the solid principles. So what does solid principles stand for? So first, S stands for single responsibility principle, O stands for open closed principle, L stands for Liskov substitution principle, I stands for interface segregation principle, and D stands for dependency inversion principle. And let's see the benefits of the solid. First, whenever we apply solid principle into the system, the code is easy to understand and reason about. Changes are faster, and there is minimal risk. Highly maintainable code over the long period of times, and cost effective, both time and money. So let's see the single responsibility principle first. So as the definition of the single responsibility principle says that every function, class or module should have one and only one reason to change. So as a programmer, we always come across some kind of responsibilities. So let's see some examples of responsibilities. First is business logic. Second is persistence, user interface, logging and telemetry, orchestration, and users. So these are some examples of responsibilities. Apart from that, we have input, output, error handling, etc. So what are the consequences of not using the SRP? So code is more difficult to understand, maintain, and evolve. Code is hard to test, which leads to high bug count and regressions. There are lots of side effects, and there is a high coupling. So why should we use SRP? So it makes code easier to understand, fix, and maintain. That it leads to a testable design with fewer bugs. Classes are less coupled and more resilient to change. So let's identify the multiple reasons for a component to change. So if statements are a good indication that the method is doing too many things. So let's see this example here. So this is a method that calculates or that finds out whether the distance between the two trains is safe or not. So first we are calculating the distance between the current train and the other train. And if the distance in feet is greater than 200, then we have some set of rules and calculations. Else, if the distance is less than 200, then we have some other set of rules and calculations. Like if the speed of the train is safe or is in safe range, then we have some different rules. If the train is equipped with power brake, then we have different rules, and we have some generic rules. So there are lots of rules that are being handled in this if and else statements. This method can change for many reasons. Like if any of the rules in any of the if block changes, then this method gets changed. So one thing we can do is to move this logic into a separate class or a service, and we can call that service from this service. So switch statements can also give us a clue that the method is doing more than what it should be. So let's see an example. We have a method that is can stop. So it finds out whether the train can stop or not. So depending upon the type of the train, we have some heavy logic, right? We have some heavy logic for each case. If the type is express, then we have to check some express rules and time limits and check track capability. If the train type is high speed, then we are applying some high speed rules and time limits. And for the passenger trains, we are applying medium rules and time limits. So based on the type of the train, we are applying some different sets of rules and calculations. So here as well, we can apply the same logic. We can move this logic of whether the train can stop or not into a separate class or a service. So one important point that not all if and switch statements are evil. If it means that if they don't contain heavy logic, then they are okay. So if we see this example, like in is fuel alert on, if the fuel quantity is less than 100, we are just returning true and false. Right? And in the second example, we are just returning the error name based on the error code using the switch case. So if we are taking the parameter in the switch and we have some cases like E126, E375, and we are returning the error name. So there is no heavy logic here. So we can allow this if and switch statements. So now let's see what we call the monster method. So here is an example of train plan scheduler. So here we can see we have a method that is schedule train plan that takes input the train plan. So here we are first checking whether the train plan is valid or not, and if it is not valid, then we are printing or we are logging that train plan is not valid. If the train plan is valid, we are finding the available time slot from the database. And if the available time slot is equal to null, then again we are logging the warning statements. If the available time slot is not equal to null, then for the current train plan, we are assigning that time slot. And finally, we are notifying all the stations for this train plan. So if you can see, we have multiple reasons of change in this method. We are dealing with the logging. We are directly dealing with the database repo instead of the interface, right? So if the internals of the database changes, then this method will also change, right? We are notifying stations. If some more notifications get added or reduced, then this method will get changed. So there are three reasons for this method to be changed. So now let's see the utility classes. So in every project we have some utility classes or what we call the helper classes. So one example is train traffic management utils. It has four methods. That is, first that it calculates the distance between the train 1 and train 2. Second and third methods are doing some conversions, and fourth is kind of a validation method. Here Instead of having all the different types of logics in one utility method, we can have three different utility method. First, for calculating the distance. Second, where we can have the second and the third method, which are dealing with the conversions, and the fourth, which is doing some kind of validation logic. So let's see the another responsibility, that is users. So suppose we have a generic reporter class that generates reports for different actors. Like it generates report for superintendent, training department, and technical staff. For each of these actors, it is generating a generic report. But suppose the superintendent wants to know that how many days the driver took off or rest between a journey, then this information is useless for training department and technical staff. So one report cannot solve the purpose for all the three actors. So what we can do is we can have three different methods which generate train report for three different actors, right? So at first the logic may be the same in all the three methods, right? So here we are breaking the do not repeat yourself principle, but to be more future flexible, right, we are breaking this rule. So we can have two different classes altogether. One is training staff reporter builder that generates the report, train report for the training staff. The other can be superintendent report builder that will generate the train report for the superintendent, and the likewise for the third class. Next is orchestration. That is also one of the responsibility that we saw, right? So in this train plan scheduler, we can see that we have a database repo, we have a email service, we have a train dashboard service. Right? So what we are doing is the responsibility here is that it is orchestrating the scheduling of the train plan. Right? So we have a method that is schedule train plan that takes into the train plan. First, it is finding from the database repo the free time slot. If the available time slot is equal to null, then we are logging some warning messages. And if there is a available time slot, then we are assigning that time slot to that train plan. We are notifying all the passengers for that time plan, and also we are publishing on the dashboard service. So this train plan scheduler is orchestrating all these business logics. So here we can see too many dependencies in this train plan scheduler, right? So how we can solve this problem is by using events, right? So when we use events, then the coupling is low and the components are more focused. So from the previous example, what we have done is we have removed the email service and the notification service, and we have kept the database repo and the event handler. So this method will not change, right, if the dependent parties they need to react when a train plan is scheduled. Right? So in the same method, that is scheduled train plan that takes the train plan, we are first finding from the repo the free time slot, and if the available time slot is equal to null, then we are logging some warning messages. Otherwise, we are assigning that time slot to that train plan. And once the available time slot is assigned to the train plan, we are publishing the event, that is train plan scheduled event, with all the information that is train plan and the available time slot. And we can have some event handlers, like the other services like email service and the dashboard service can implement the handler for that particular kind of event, that is train plan scheduled event, and they can perform some operations, that they can send email to the passengers interested in this train, right? Likewise, the dashboard can listen to that event implementing that handler of event type, that is train plan scheduler event. So in this way, that components that need to react to an event are also more focused, right? We can add as many handlers without modifying the code that does the train scheduling. So even if we are having multiple handlers, the train plan scheduler class will remain unchanged. So SRP principles applies to package as well. Right? We can have different components or different classes in different packages. Like we can move different components into different packages so that they are more cohesive. So till now we saw the codes that are breaking the single responsibility principle. Now let's see the path that will lead to SRP, or what we called is refactoring to SRP. So first we have to identify the reasons to change. So we have seen all the different reasons our component can change in our previous slides. Now then we have to refactor the same. So for refactoring, sometimes creating a separate method is sufficient, and sometimes we have to create altogether a new class and we have to move all the responsibilities in a different class. We can create coherent packages, and we can use events to limit the dependencies or lower the coupling. Let's see an example where we will see that the single responsibility principle is not adhered, and then we will refactor it to the single responsibility principle. In this example, we are finding all the trains whose distance is less than a particular range. So in the class origin, we have two fields, that is origin latitude and origin longitude. We have a method that is get train in range that takes input range, all trains, and latitude first. So range is an integer value, and all trains is of type list of train target, and train target has attributes ID, latitude, and longitude. So first we are trying to find all the trains whose distance is less than the range. So we are starting with all trains. We are making a stream, and with the this formula, that is distance formula, we are filtering the trains whose distance is less than equal to range. And finally, we are collecting all the trains in the variable that is train in range. And if the boolean value latitude first is true, then we are printing the coordinate of each trains first with the latitude value and then with the longitude value. And else, if the latitude first is false, then we are printing first the longitude and then the latitude. So in the program class, we have a main method. In the main method, what we are doing, we are first creating the list of train targets, right, with all these values, and then finally we are calling the constructor of the origin class with the origin latitude as 0 and origin longitude as 0. Now first we are calling get train in range with the value 6, and we are passing all the trains, and we are setting latitude first as true. And then we are calling get train in range method with range 6 and all the trains, and latitude first as false. Now if we try to run this program, so we will see this kind of output. So here in the origin class, we can see that it is not following the single responsibility principle. First, it is calculating all the trains which are in range, and then it's printing the coordinates of all those trains with a if else block. So there are two responsibilities that are being catered in this class. So what we can do with this class so that it follows single responsibility principle. So here we can see that it is printing the coordinates of all the filtered trains which are in range. So what we can do, we can create a class coordinate output formatter. So here I have created coordinate output formatter. So I have created the latitude first boolean variable. I have also created the parameterized constructor with the latitude first as a parameter. So whenever the coordinate output formatter is initialized, then the latitude first value has to be passed. Now I can create a public method that is parse output. Now I have created the parse output method. I can go into the origin class, and I can remove this part of logic from this class and paste it into the new class that I have made, that is coordinate output formatter, and I can take the list of target trains as an input. So in the coordinate output formatter, I have copied the code for printing the coordinates of each filtered trains that are in range, and in the class that is origin, we can remove this latitude first parameter, and we can take coordinate output formatter as an input parameter, and we can call output formatter dot parse output with all the filtered trains. Now, so in the main program, we have to pass the coordinate output formatter in the method get train in range. First, we will create the coordinate output formatter with latitude longitude formatter, and we will pass the true as a parameter. And we will pass this variable as a parameter in the method get train in range. And the second time, we will create a longitude latitude formatter with a latitude, and we will pass this longitude latitude formatter as a input parameter to the method get train in range. And now if we run this program, we are getting the same result. So and in this way, we have made the class origin to only handle one responsibility, and the second responsibility, that is printing the output, has moved to a new class, that is coordinate output formatter.